So when graphing the cosine, since we know the way the graph is going to be shaped, I'm just going to pick those 5 critical points, and then I'm just going to graph those out. So we're going to find, remember this is your angle here, theta. We're going to find the cosine for each of these angles. So I know it says y here, but try not to get too bogged down on that. This is, right, y is the cosine of your angle. And remember, cosine means the x, right? I want the x value. So at 0, I want 1. At pi over 2, I want 0. At pi, I want -1. At 3 pi over 2, I want 0, and then back to 1. So let's go ahead and plot those points out. So at 0, I get 1. At pi over 2, I get 0. At pi, I get -1. At 3 pi over 2, I get 0. And at 2 pi, back to 1. So I'm going to go ahead and graph those points. So I've got 0, 0, 0, 1, sorry. So 0, and we're going to go by halves this time. This is a half, and this is 1. So there's 1. So notice how cosine is going to start at 1. Remember, sine started at 0. Then at pi over 2, we hit 0. Then at pi, we hit -1. Sorry, this is -1. Then at 3 pi over 2, we hit 0, and then we go back to 1. Now remember that this is going to be kind of curvy, right? Kind of the way the sine was. So this one's going to look something like that. And there we go. That's going to be the graph of your cosine. And remember, all we're doing is we're just taking these curves here, and we're just putting it on the graph, right? Now I'm taking this curve right here, and I'm putting it right there. Then I'm taking this curve right here, and that's the one that goes right there. And then I'm taking this curve right here, and I'm putting that one right there. So that's all that's going on. Okay, so I want to identify some features of this graph. So I wanted to give you guys a second to look at this graph and see if you can identify which graph it is. Is this the sine or is this the cosine? So if you guys notice, this graph is going to be the sine, right? How do I know this is going to be the sine? Because the sine is always going to start at 0, and then from there it's going to go up, right, to 1, back down to 0, then to -1, and then back up to 0, right? That's always going to be the shape of the parent function. So what I want to do now is I want to identify some features of this graph. I want to identify the domain. I want to identify the range, amplitude, and we'll talk about what the amplitude means, period, x-intercepts, y-intercepts, intervals of increase and intervals of decrease. So let's start with the domain of this function. Remember, the domain are going to be all of the possible x values, right? So whenever I think of domain, I think of what are my possible x values. Okay, my x values are angles and radians, but if you notice, they go on forever, right? It starts at 0, and it goes forever to the right. Here we go forever to the right and forever to the left. Right, so whenever that happens, we know that's going to be all real numbers. So our domain here is going to be, we can say all real numbers, or we can say it goes from -infinity all the way to +infinity. The range, right? Remember, the range of my y values. So my range is just going to be, well, what's the highest value? What's the lowest value? Well, if you notice the range here, the highest value this is ever going to hit is 1, and the lowest value it's ever going to hit is -1. So this is the range, right? The range just goes from 0 to, right, from -1 to 1. So my range is, we can say it goes from -1 all the way to 1. Or we can write this in interval notation, and we can say it goes from -1 to +1. So either way you write it. Okay, now let's talk about the amplitude, right? So the amplitude is going to be just going to be the distance from the the distance from what we call the midline of the trig function to the highest or lowest point. So what is the midline? So every one of sine or cosine has something called a midline. The midline is just going to be a line that is the same distance from the highest to the lowest point. So in this case, this is going to be your midline. So the amplitude is going to be the distance from that midline to the highest point right there. So that we call the amplitude. Right, that's the amplitude right there. And then same thing going down, right? The distance from that midline to the lowest point, that is also the amplitude. And the amplitude is always going to be positive, right? We're always going to consider it as positive. If it is negative, then that's just going to really just change the direction, but we'll get to that as we see it. So, okay, amplitude. So we're going to say it's the distance. Let me type it. I'm a much faster typer than I am. So it is going to be the distance oh no, what's going on here? So it's distance between the midline and the highest or lowest point. Okay. Perfect, right? So that's going to be your definition of the amplitude. And in this case, the amplitude is just going to be 1. Right? Our amplitude is just 1 here. It's a distance of 1 unit, right? It's just 1. Okay. Next thing is the period. So what's the period of this trig function going to be? So the period is basically how long it takes for the values to start repeating a whole cycle. All right, so if you notice here, well, how long does it take to go around the unit circle? Well, it starts here at 0, then it goes all the way around, and then once it hits 2 pi, then it's going to start all over again. Right, then it's going to start all over again. So then we'll have another period. We'll have another period right here. Whoops, that doesn't look good, but we'll have another one right here that looks like that. And then we can even keep on going. Then another one, right? Then and so on and so forth. So the length of one period is going to be, right? The length of one period is it's going to start right here, and then it's going to end right at 2 pi. So this is just one. This is what we call one period. It's like one cycle around the unit circle, and we have another period over here too. So this is one period too, from there, from negative 2 pi all the way to 0, right? That's another period. So we can see it. There's 1, and then there's 2. So in this case, the distance of the period is just going to be 2 pi. It's just going to be 2 pi. Let's look at the x-intercept. So for the sine function, if you notice the x-intercepts, where does it hit the x-axis, right? It hits the x-axis here, I hit the x-axis here, I hit the x-axis here, right? So if you notice, it's every interval of pi. So all we're going to say is the first one starts at 0, and then every time you go either left or right pi, you're going to hit another 0. Or in this case, we're going to add a k to it because this goes on forever, right? It goes to the right forever, and it goes to the left. So that k is going to control how many times you go to the right or to the left. Okay, for the y-intercept, so in this case, with the parent function, if you notice, where does it hit the y-axis? Well, it's going to hit the y-axis right at 0. So in this case, there's only one y-intercept, and it's at 0. All right, now we look at intervals of increase and decrease. So let's see, intervals of increase and decrease. So an interval of increase, right, would just be where is it increasing, right? So it's increasing from here all the way to here. It's increasing from this point all the way to that point, 2 pi. So let's figure out what are those values. So this is increasing from 0 all the way to about pi over 2. Then it increases from 3 pi over 2 all the way to 2 pi. And then let's look at the decrease now. So now it's decreasing from there all the way to there. So those points are going to be, so it is decreasing from pi over 2 all the way to 3 pi over 2. Oh, let me change some of these because this one actually includes 0. Right, this includes 0 here, so we're going to put a bracket since it includes 0. And then same thing on that last one, it includes 2 pi, so we're going to go ahead and put a bracket there. All right, so there we go. Those are all the features of sine. Okay, so now let's go ahead and look at all the features of cosine. So first thing we notice about cosine, notice that at the y-axis here, cosine is going to start right at 1. So that's how we can differentiate it between sine. And let's go ahead and look at the domain. We know the domain is going to be similar to what sine was, right? This goes to the left and to the right forever. So we can say all real numbers, or we can say from negative infinity to infinity. All right, it goes on forever. The range, same idea with the range. The range is going to go from -1 all the way to 1. Or we can say from -1 to 1 if we wrote it in interval notation. The amplitude, the distance from the midline to the highest point, is still 1. The period is still going to be 2 pi, right? That's how long it takes for this for the function to go to start over again. So right, we can see it there. If we go backwards, we'll see another period there. So it's going to be a distance of 2 pi. Now x-intercepts for cosine are a little bit different. If you notice that this one is going to start right here at pi over 2, and then it's just going to go a distance of pi, right? So all the x-intercepts are going to start at pi over 2, and then they are still going to go and they're going to repeat every interval of pi. So we say pi times k, right? So if k is 1, then it'll go forward 1. If it's -1, then it will go backwards measurement of pi and end up at the next 0. So that's all that's saying there. The y-intercepts, well, this one has one y-intercept, and we can see it at 1. The interval of increase, so we can see that it's increasing, and I'm just going to look at one period, right? I just want to look from one period, from here to here. So the interval of increase, we can see it's increasing here at pi, and then it increases right up until 2 pi. So it starts increasing right at pi, and then it goes all the way to 2 pi. And then for decrease, we're going to start at 0, and we're going to go all the way to pi. So here we're going to start at 0, and then we're going to end up right at pi. And there's our interval of increase and decrease.